Imagine proposing a massive glass and steel pyramid for the central courtyard of the most famous museum in the world, a historic palace that is a symbol of French culture and history. The outrage was immediate and fierce. Critics called it a monstrous, sacrilegious annex that destroyed the dignity of the Louvre. Yet today, I.M.Pei's Louvre Pyramid is as iconic as the Mona Lisa herself, a symbol of a bold, forward-looking France. But how did this happen? How did a structure that seemed so alien become so essential? The answer lies not just in the stunning visual concept, but in the invisible engineering, the painstaking material science, and the brilliant urban planning that solved the Louvre's very real functional crisis. This is the story of how a controversial glass object became the beating heart of a modern museum, and the incredible structural secrets that make it seem to float weightlessly above the courtyard. The Louvre in the 1980s was a congested, confusing maze. Visitors entered through a small, overcrowded door into a labyrinth of corridors. The museum lacked central services, proper circulation, and a clear entrance sequence. But how do you bring light into a subterranean space and create a monumental symbol for this new entrance? The answer was the pyramid. But from an engineering perspective, a glass pyramid was the only solution that provided the necessary light while maintaining a transparent, non-intrusive presence that respected the historic facade surrounding it. A pro tip for any architect working in a historic context is that transparency and reflection can be tools for deference, not dominance. The pyramid reflects the sky and the old palace walls, constantly changing and never imposing a single solid form. The real magic of the pyramid is its structure, a masterpiece of minimalism designed to disappear. Supporting 95 tons of glass and steel over a 116-foot square base, with a surface area of over 10,000 square feet, using a traditional frame would have created a thick, obstructive web of mullions. The solution, engineered by the legendary Peter Rice of Louvre and Partners, was a revolutionary two-layer system. The primary structure is a delicate space frame, a three-dimensional truss made of thin, interlocking steel members. But the true innovation is the secondary structure, a custom-designed cable-truss system that holds the glass panels, instead of thick aluminum frames. The glass is held in place by stainless steel castings and tension cables. This system is incredibly lightweight and almost invisible, maximizing transparency. Each of the 603 rhombus-shaped and 70 triangular glass panes is supported independently, allowing the structure to flex slightly under wind and thermal loads without cracking. A common and catastrophic mistake in early structural glass designs was making the connections too rigid, which would transfer stress directly into the glass. Here, the flexibility is a feature, not a bug. Then there's the glass itself. This was not standard window glass. To achieve the crystal-clear, colorless transparency I.M.Pei demanded, a special white glass formula had to be developed. Standard glass has a slight green tint caused by iron oxide impurities, which would have been magnified and turned the pyramid into a murky green mass. The French glass manufacturer Saint-Gobain was tasked with creating a new, low-iron glass that offered exceptional clarity and light transmission. Furthermore, the glass had to be laminated for safety and security, consisting of two panes with a plastic interlayer to prevent it from shattering into dangerous shards. A workflow secret on a project of this precision was the use of full-scale mock-ups. Before any glass was cut for the final structure, a full-scale section of the pyramid was built to test the connections, the optical quality, and the waterproofing. This level of pre-construction testing is non-negotiable for bespoke, high-stakes projects, saving millions in potential rework. The construction process was a ballet of precision. Set against a backdrop of intense public scrutiny, the foundation for the pyramid is a massive concrete ring beam that distributes the loads evenly into the ground. carefully avoiding the archaeological layers and existing structures below the courtyard. The steel structure was prefabricated off-site to tolerances of less than a millimeter. The erection sequence had to be perfect, as each component relied on the others for stability. A major challenge was the complex geometry. Every node in the space frame and every glass panel is unique. The installation of the glass was the final, dramatic act, using custom-designed cranes and rigs. Each panel was carefully lowered into its precise position in the cable net, a process that required perfect coordination and a steady hand. The result was a structure that seems to be made of pure light, with its structure dematerialized into a faint, elegant line drawing. In conclusion, the Louvre Pyramid is a testament to the power of engineering to enable architectural poetry. Is not merely a symbol, but a highly sophisticated machine for capturing light and organizing space. It demonstrates that the most powerful intervention in a historic context can be the one that is transparent, lightweight, and respectful of the past while boldly embracing the future. It solved a critical functional problem with a solution of breathtaking elegance and technical brilliance. As a final note on innovation, the pyramid stands as a reminder that public opinion can evolve. What was once reviled is now beloved. It teaches a lesson in having the courage to pursue a vision backed by rigorous engineering and a deep understanding of a project's core needs, even in the face of overwhelming criticism. If this deep dive into the secrets of the Louvre Pyramid has given you a new appreciation for it, and you'd like to see us explore other controversial modern landmarks, let us know in the comments. And if you're learning from this, please support the channel by subscribing for more expert-level architectural breakdowns.